Due to the low efficiency of electro-optical conversion, lasers require a high power to achieve functions such as cutting and welding. As a result, laser equipment naturally generates a significant amount of heat that needs to be dissipated. In this video, we will discuss various cooling solutions for different laser devices. A high-power fiber laser's core is the pump source, which is the component that generates the laser. Due to the substantial heat generated, the pump source is typically made of copper and mounted on an aluminum plate, which serves as the pump source's heat sink. On the other side, the laser produced by the pump source is continuously amplified within the gain medium optical fiber, while the fiber is fixed in aluminum circular groove for heat dissipation. To dissipate heat for the pump source and optical fiber, on one hand, we embed heat pipes beneath the heat source to achieve better temperature uniformity. On the other hand, we use a fin skeeving process to create very dense fins, increasing the heat dissipation area. This is a typical air cooling solution for fiber lasers. As the thermal consumption of fiber lasers exceeds 2,000 watts, liquid cooling solutions are becoming more prevalent. They can more stably and rapidly control the core temperature of the pump source, enabling higher power output, and are widely used in high-power laser cutting and welding machines. In recent years, the power of fiber lasers has been increasing, and they are also being applied to smaller, lower-power devices by manipulating the laser controller to move the laser on a horizontal plane. A desktop laser engraver can complete the task of engraving desired patterns onto materials like paper and wood. For such laser engravers, we also have custom small heat sinks designed specifically for them. Lasers are also widely used in the medical field where the quality requirements for lasers are particularly stringent. Consequently, temperature control is even more critical. In the examples mentioned above, a combination of heat pipe heat sinks and thermoelectric coolers is used to maintain the pump source at a relatively low temperature. The challenge in cooling laser hair removal devices lies in managing to keep the sapphire mirror, which comes into contact with the skin, at a temperature below body temperature within a very compact volume. Here, we also utilize thermoelectric coolers to further reduce the temperature and expel the heat through a fan at the rear end. Great. The information above provides a basic understanding of laser cooling. We hope it can be of assistance to those of you who are watching the video. If you have any questions, feel free to communicate with us at any time. Thank you for watching.